Alright guys, now we're solving quadratic equations using interpolation, and in this segment we're going to meet Mr. Discriminant, and he's a very, very nice man to know in the land of the quadratic. So I'll just fast forward through the slides which I dealt with for interpolation, that one and that one, and then we'll just go straight into Mr. Discriminant. So the question we want to have the answer for is, how many solutions are there? Because quadratics are funny beasts. They don't always have a solution when you say y equals 0. Okay? They can have no solutions, or one solution, or two solutions, depending on the quadratic which we have here. Okay? So to sort that little bit of a puzzle out, we're going to introduce Mr. Discriminant, and he is a very, very good man to know, as I keep telling you. Now, we know that for a quadratic equation ax squared plus bx plus c equals 0, if we use the quadratic solution for that, guys, we know that x is equal to, now just don't worry about that little bit of a dividing line there, just that shouldn't be there. Should say that x is equal to just this bit over here. It's minus b plus or minus the square root of b squared minus 4ac over 2a, and I do recommend that you learn that off by heart, okay? That is the quadratic solution, which is arrived at by completing the square on this generalized quadratic trinomial up here, equals 0, alright? Now, the expression under the square root sign, that is the discriminant, that is the beast, okay? B squared minus 4ac. That is called the discriminant, and the discriminant will tell us whether there are 1, 2 or 3 solutions to our quadratic. Yes, I know, it is strange but true. So the notation we use is the capital Greek delta. That's what we use, the term we use for the discriminant, alright? Now, case 1, if the discriminant is greater than 0, there will be 2 solutions. Now, I will briefly explain that to you as to why. You see, you've got this thing up here, this solution to the quadratic equation equals 0, x equals all of this. Now, if the thing under the square root sign is positive, then that is a viable square root term, okay? You're allowed to have square roots of positive things, yes? You can have square roots of positive things or 0 things, but never negative things, and that's the crux of what we're going on about here with Mr. Discriminant. So if this b squared minus 4ac is positive, then you will get x is minus b plus or minus something which makes sense over 2a, and therefore you're going to get 2 solutions, minus b plus something over 2a and minus b minus this something over 2a. You can see quite clearly that will give you 2 answers, won't it? It will, okay? Case 2, guys, if the discriminant is less than 0, then the whole thing is completely crazy, because you cannot have the square root of something negative. You try it, okay? If I said to you, what is the square root of minus 4? Could you come up with something? No, because minus 2 times minus 2 is plus 4. You see, nothing multiplied by itself will ever give you minus 4. So you can't have the square root of a negative number. So if you get something negative for the discriminant, then this whole thing is a complete nonsense and there are no solutions, yes? Okay, now case 3 is where the discriminant equals 0, in which case this whole square rooty term is nothing. So if you just basically blank that whole square root thing out of your mind because it equals 0, you will just end up with x is minus b over 2a, which is obviously just the one solution, right? There's no plus or minus anymore because all of that stuff equals 0. That's how it works. Isn't he a handy little devil, that Mr. Discriminant? So for case 1, we have 2 sub-cases of that. For the discriminant is, now that should read, I'm just going to fix that. abracadabra, I've just fixed it. And by the way, I just fixed this thing up here. So this is right now, okay? Makes sense. Now, the two subcases, this is for when the discriminant is greater than 0. That's case 1. I accidentally had an equal 0 there. I must have been having a bit of a bad moment at that time when I wrote that. There are two subcases when the discriminant is positive or greater than 0, guys. Now, first of all, if the discriminant is a perfect square, if the discriminant is a perfect square, then it's easy to take the square root of it and get a whole number solution, in which case that means that your x values will be just rational solutions. In other words, they'll either be fractions or whole numbers, but there won't be any 30 bits, okay? That's what that means, guys. And if the discriminant is not a perfect square, then it's third land. We're going to have 30 solutions, okay? Do you get that? All right, now, here we go in pictorial form. Case 1, if the discriminant is greater than 0, there's a perfect example of that, okay? We've got two rational solutions here. If it was a perfect square, then they would be rational or whole number solutions, okay? If it was not a perfect square, these could still be the solutions, but they wouldn't be rational. They'd be 30 bits, okay? And we'd have to do approximations to get them to work out where they were exactly on the x number line there, yeah? Okay, so this is representing where it's not, where the discriminant is positive but not a perfect square. We're saying that they would be irrational, but they're still perfectly viable solutions. They've just got 30 bits in them when you work out what they are, if you know what I mean. You do know what I mean, I know that. So therefore, here's case 2, when the discriminant is less than 0. We don't have any solutions. In other words, y never equals 0, okay? It's above the point where y equals 0 here, which is down the x-axis where it equals 0. It's above there, so it never gets to 0 in that case. And it's below there, okay? So it never gets to the 0 point for y in that case there. You see? So that's discriminant is less than 0, okay? Case 3, pictorially, when the discriminant equals 0, there you go, only one solution. It just comes down and just touches the x-axis, like, you know, like a Halley's Comet comes in here, just touches, and it just goes flying out into outer space again. And the same thing for this upside down one over here. There's only one solution, and the discriminant equals 0 for that case. Okay, now we better do some examples here and see how we go with it. Now, we've got this first one. All right, so by using the discriminant, okay, state whether the following equations have 0, 1, or 2 rational or 2 irrational solutions. No problem. Okay, so let's do it. Now, okay, discriminant is b squared minus 4ac, in case you forgot. Now, the b would be minus 1, the a would be 1, that's the coefficient of the x squared term, and the c would be minus 12. So there you go. So it's b squared minus 4ac. Looks like it's going to be positive. Yes, oh, look at that. It's 49, and that's a perfect square. So that's going to be 2 rational solutions. Yes, 2 solutions, and because it's a perfect square, they will be rational, which means fractions or whole numbers. You get the idea, don't you? All right, next one. You know what to do. Come on, Mr. Discriminant, where are you? There you are, b squared minus 4ac. That looks like that's going to be, ooh, goodness, look at that. It's going to be 0, so there is one solution. See how this is really good fun, isn't it? It's easy to do. Part C, now we've got to work that one out now. The b squared minus 4ac comes to that. Now what's, oh, goodness, look at that. It's 301. Now that's certainly not a perfect square, but it's positive, so it means 2 solutions, but they will be irrational. Yes, very good, excellent. Now let's go for D now, and I think we're nearly finished. Goodness, okay, let's do D. D, there you go. So b squared minus 4ac would be minus 9 all squared minus 4 times 1 times 108, which gets us, ooh, something negative. Therefore, there are no solutions to that, you see? You get it, guys? It's very, very simple. See how useful Mr. Discriminant is? And you're a star, and you'll go far, huzzah. So, go and do some practice and have a wonderful time in the land of the quadratic, and we'll see you soon.